In this video, we're going to solve rational equations. When you have a single expression on one side, and you also have a single expression on the other side, then what you could do is you can cross multiply. So you get 3 quantity 4x plus 5 equals 9 times the quantity x plus 1. And all you got to do is just solve for x. You get 12x plus 15 equals 9x plus 9. Subtract 9x both sides, you get 3x plus 15 equals 9. And 3x equals negative 6. Therefore, x is equal to negative 2. Now, only thing that you need to be careful is when you plug in negative 2 for x, denominator cannot go to 0. So be careful with that. In this case, this is fine. So that will be the solution. Now, another way of doing it is we could multiply both sides by the LCM. So for example, what is the LCM of this expression? Well, LCM is going to be x plus 1 times quantity 4x plus 5. So what we're going to do is multiply both sides by x plus 1 and then 4x plus 5 to both sides. So what happens here? Here, x plus 1 cancels out. You get 3 times quantity 4x plus 5. What about over here? 4x plus 5 cancels out. You get 9 times x plus 1. So you end up getting the same thing. Now, you can only cross multiply. Again, you can only cross multiply when you have a single expression on the one side of the equation, and you also have a single expression on the other side of the equation. Now you have 5 over x plus 7 over 4 equals negative 9 over x. Unfortunately, we cannot cross multiply here because you have more than one expression here. 1, 2. You have 2 rational expressions. So what you need to do is you got to multiply each term by the LCM. In this case, it will be 4x. So let's multiply each term. Let's distribute each term by 4x. So you're going to get 20x over x plus 28x over 4 equals negative 36x over x. So what happens is the x cancels out, you get 20 plus 28x over 4 is 7x equals negative 36 because x cancels out. So what happens here? You get 7x equals negative 56. So x is equal to negative 8. Now, when you plug in negative 8, denominator does not go to 0. And also, you want to check. You probably want to check if 5 over negative 8 plus 7 over 4 is equal to negative 9 over negative 8. And when you do that, you will notice that they are equal to each other. So therefore, x is equal to negative 8. And that is a solution of this rational equation. Now, take a look at this rational equation. First of all, we could rewrite 1 as 1 over 1 if you want. Now, what is the LCM? LCM is going to be x times x minus 5. These common multiple will be x times x minus 5. So let's multiply each term by LCM. So what do you get? You get x times x minus 5 And what about over here? You get minus 8x, x minus 5 over x minus 5 equals 3x, x minus 5 over x. So you end up getting x times x minus 5. That cancels out. You get minus 8x equals x cancels out. You get 3 times quantity x minus 5. Now we need to solve for x. See how like all the denominators they are gone now? That's so nice about multiplying each term by the LCM. Now you get x squared minus 5x minus 8x equals 3x minus 15. So you get x squared minus 13x equals 3x minus 15. This will be x squared minus 16x plus 15 equals 0. So you get x minus 15, x minus 1 is equal to 0. This means x is 15 and x is 1. Let me write it right here. X equals 15 or x is equal to 1. Now, we got to make sure that there are both solutions. So let's plug in 15. You get 1 minus 8 over 10. Is that equal to 3 over 15? Well, it's going to be 1 minus, let's reduce, 4 over 5. That's going to be 1 over 5. When you reduce 3 over 15, that is 1 over 5. So x equals 15 is a solution. What about 1? You get 1 minus 8 over negative 4 equals 3 over 1, which is going to be 3. So this is going to be 1 minus negative 2, but negative times negative is positive. So 1 plus 2, is that equal to 3? Yes, it is. So they are both solutions, x equals 15 and x equals 1. Now let's take a look at this equation here. What will be the LCM? First, let's factor out x squared minus 9. You're going to get 6 over x minus 3 equals 8x squared over quantity x minus 3 times x plus 3 minus 4x over x plus 3. So if you look at all the denominators, right, LCM is going to be quantity x minus 3 times quantity x plus 3. All these denominators can go into LCM. So what we're going to do is we're going to multiply each term by LCM. X minus 3, x plus 3. Let's distribute. So you end up getting, notice, x minus 3 will cancel out. So you're going to get 6 times x plus 3. What about over here? They all cancel out, so you just get 8x squared when you multiply these two. What about when you multiply these two? X plus 3 cancels out, so you get minus 4x times x minus 3. So let's distribute. You get 6x plus 18 equals 8x squared minus 4x squared plus 12x. So you're going to get 6x plus 18 is equal to 4x squared plus 12x. I'm going to put everything on one side. So you get 0 equals 4x squared plus 6x minus 18. And let's divide everything by 2. You could do that because it's an equation. So you get 0 equals 2x squared plus 3x minus 9. And it looks like we need to factor this. So, by the way, if it's not factorable, you could also use a quadratic formula to solve for x. So 2 times negative 9 is negative 18x squared. And what are the factors of negative 18x squared? When you add them up, you get positive 3x. Well, that's going to be 6x and negative 3x. So I'm going to rewrite this. I'm going to rewrite it as 2x squared plus 6x minus 3x minus 9. And we got to do factoring by grouping. So you end up getting, what's the greatest common factor? 2x. You get x plus 3. What about over here? Negative 3. So you get x plus 3. So x plus 3 is a common factor. So let's take out x plus 3. And you get 2x minus 3. And that should equal to 0. So what are the x's? We know that 0 equals x plus 3. And 0 equals 2x minus 3. So x has to equal to negative 3. Or x is 3 over 2. So we have two possible solutions. X equals negative 3 and x equals 3 over 2. Now we have two possible solutions, but we got to be careful. One of them or both could be extraneous solutions. So when you plug in negative 3 to a denominator here, it makes this denominator go to 0 and also this denominator go to 0. So x equals negative 3 does not work. It's an extraneous solution. And what about 3 over 2? You'll notice that, first of all, the good news is that 3 over 2, it does not make the denominator go to 0. And also, when you plug it in, it will work. Now, most of the time, when you get a solution, and if that solution does not make the denominator go to 0, most likely that is a solution. But you want to double check to make sure if you have time.